Welcome to our channel. In this lesson, I would like us to discuss Form 4 Chemistry, Topic 1, Acid, Base, and Salts. In this topic, you need to know definition of acid, definition of base, factors that affect the strength of acid and base. Now, to start with, an acid is a proton donor. When you say a proton donor, we mean it gives out hydrogen atom to a base. Example, look at this equation. You have ammonium ion plus water molecule. It gives you ammonia plus hydronium ion. So in this equation, you must be able to understand that ammonium ion is the acid. Why? Because as you can see, it gives out, that is, it donates hydrogen atom to water molecule to form hydronium ion. Now, this definition of acid is known as Bronsted-Lowry definition of acid. Now, an acid can also be defined as a substance that dissociates in water to produce hydrogen ions as the only positive ions. Look at this example. We have HCl, aqueous. It dissociates in water to form hydrogen ions, which is the only positive ion, plus chloride ion. This definition is known as Arrhenius definition of acid. Now, from there, we have a base. A base is defined as a proton acceptor. When we say a proton acceptor, we mean it receives hydrogen atom from acid. Look at the equation below. You have ammonia plus hydronium ion, arrow, get ammonium ion plus water molecule. So in the equation above, you must be able to understand that ammonia is the base. Why? Because as you can see, it accepts, that is, it receives hydrogen atom from hydronium ion to form ammonium ion. We have another definition of a base. A base is a substance which, when dissolved in water, it dissociates to produce hydroxide ions as the only negative ions. As you can see, we have sodium hydroxide. It dissociates in water to form sodium ion and hydroxide ion, which is the only negative ion. Now, from there, we need to know factors that affect the strength of acid and base. For their strength is affected by 4 factors. Number 1, degree of dissociation. Number 2, pH. Number 3, electrical conductivity. Number 4, chemical reaction. Now, to start with the degree of dissociation, strong acid is one which dissociates completely when dissolved in water to produce many hydrogen ions. Examples include dilute hydrochloric acid, dilute sulfuric acid, and dilute nitric 5 acid. A weak acid is one which dissociates partially when dissolved in water to produce few hydrogen ions. Examples, they include ethanoic acid, carbonic acid, and methanoic acid. A strong base is one which dissociates completely in water to produce many hydroxide ions. Examples, they include sodium hydroxide, potassium hydroxide. A weak base is one which dissociates partially when dissolved in water to produce few hydroxide ions. Examples, they include ammonia solution, wood ash solution, magnesium hydroxide solution. Now, we have factor number 2 is pH. What is pH? pH is the degree of acidity or alkalinity of a solution. The acidity depends on the concentration of hydrogen ion in a solution. NB, strong acid has high concentration of hydrogen ions, while a weak acid has a low concentration of hydrogen ions. Alkalinity or basicity depends on the concentration of hydroxide ions. NB, a strong base has high concentration of hydroxide ions, while a weak base has low concentration of hydroxide ions. Now, from there, we need to know how to determine the pH of a solution. Now, for you to determine the pH of a solution, then you usually use the universal indicator solution or universal indicator paper. Now, if you are given universal indicator solution, then you add 3 drops of universal indicator solution to the sample, and then to the sample you compare with the pH chart scale. But if you are given universal indicator paper, then you take the paper and you dip in the sample, then you compare with the pH chart scale. This is how a pH scale looks like. You need to know that pH 1.0 to 3.5 is a strong acid. 3.5 to 6.5 is a weak acid. pH 7.0 is a neutral. 7.5 to 10.5 is a weak base. 10.5 to 14.0 is a strong base. NB, acidic rain is a weak acid which has a pH value of 6.5. Here we have a sample quiz. We have solution pH, solution A, pH value 1.0, solution B, pH value 6.5, solution C, pH value 10.0, solution D, pH value 13.0. With the reason, identify the solution with A, highest concentration of hydrogen ion. So the answer becomes A, because we said that strong acid has high concentration of hydrogen ion. Therefore, pH 1.0 is a strong acid. B, lowest concentration of hydroxide ion. You can try that one. Now you have factor number 3, electrical conductivity. Electrical conductivity of a solution increases as the number of ions in a solution increase. And B, the difference in electrical conductivity of a solution is compared using A, amount of brightness, B, amount of deflection on the ammeter. Note, strong acid and strong base produce greater deflection on the ammeter. They also produce a brighter bulb. A reason, strong bases and strong acids are strong electrolytes, hence they are fully ionized in aqueous solution to yield many free and mobile ions. Note, weak acid and a weak base produce lesser deflection on the ammeter, produce a dim bulb. A reason, a weak acid and a weak base are called weak electrolytes, hence they are partially ionized in solution to yield fewer ions. We have a sample quiz here. You have solution, ammeter reading. You have sulfuric 6 acid, the ammeter reading is 7.0. You have ethanoic acid, the ammeter reading is 3.0. Now, explain the difference in ammeter reading of the solutions above. The answer is sulfuric 6 acid is a strong acid, hence strong electrolyte. Therefore, it is fully ionized in solution to yield many ions. While ethanoic acid is a weak acid, hence a weak electrolyte. Therefore, it is partially ionized to yield few ions in solution. Factor number 4, we have chemical reactions. The rate of chemical reaction depends on the amount of hydrogen ions in solution. And B, the difference in rate of chemical reaction depend on number 1, amount of gas produced, number 2, rate of effervescence, bubbles that is. Note, strong acid such as dilute hydrochloric acid produces high amount of hydrogen ions when reacted with metals, and the rate of effervescence is very high. A reason, strong acid is fully ionized in water to produce many hydrogen ions in solution. And B, a weak acid such as dilute ethanoic acid produces less amount of hydrogen gas when reacted with metals, and the rate of effervescence is very slow. The reason, weak acid dissociates partially in water to produce fewer hydrogen ions. That's the end of our lesson. Thank you. For more videos, subscribe to our channel.